I realise that when we start talking genetics, it becomes quite difficult for some people who don't have much of a genetics background. As I think I explained yesterday, my training was in plant pathology, and I picked up the genetics in the work that I've done since I got my PhD. So, but if we don't at least try to cover some of the basic concepts of genetics, then it really isn't possible to understand the significance, for example, of pathotypes or races, right? Or approaches to resistance breeding. So I think the important thing is, we're going to cover a lot of territory in genetics. I think the important thing is for you just to get an understanding of some of the really basic concepts. And that's one of the real values of the quizzes, is we can just pick up on some of those really important concepts and just expand on them, particularly if we see in the quiz that you haven't understood what we said. So this morning, in the lecture I'm going to give, I'm going to talk about concepts of resistance. I mean, this is an area that's full of jargon and can be quite confusing. I'm going to cover major and minor resistance, durable resistance, working with minor gene adult plant resistance, and then we'll finish up with some stuff on genetic analysis, how we actually go about, thank you Gordon, how we go about getting to the bottom of what the genetic basis of resistance in particular varieties actually is. So I'm sure you've all read literature on resistance. These are some of the terms that you'll come across, and the list is almost endless. You read a paper, they talk about major gene resistance, minor gene resistance, seedling resistance, adult plant resistance, vertical resistance, horizontal resistance, if you go back to the work of Van der Planck, oligogenic resistance, polygenic resistance, partial resistance, slow rusting, and so on. As I said, the list is seemingly endless, and this can be very confusing because a lot of these terms either mean the same thing or they overlap. All right, we're working biological systems and they don't behave according to strict laws. Things are not black and white. However, these concepts are useful in helping us to talk about general themes and talk about resistance, okay? So it's just important to realise when we're talking about things such as durable resistance, minor gene resistance, major gene resistance, a lot of these terms we use for convenience to help us in our communication. They're not black and white. And I'll show you what I mean by that once we get into the lecture a little bit. Probably the most common terminology used when we're talking about resistance in this day and age is major gene resistance and minor gene resistance. These are some of the most common terms you'll hear, and they are more or less, but not completely, the same as saying for major gene resistance, all stage resistance or seedling resistance, and for the minor resistance, adult plant resistance, okay? So those terms are almost the same, but I emphasise that there are exceptions, and I'll illustrate what I mean by that. So from the point of view of, and as I've said there, these are terms of convenience, all right? The use of major and minor, they're really just terms of convenience. Typically, what we mean by major gene resistance is resistance that's effective at all growth stages, so all the way from the seedling right through to the adult plant, every single growth stage. There is some effect of these genes. They have a major effect on the phenotype. That's why they're called major genes. And you can see an example here. This is an adult plant leaf, right? But you can see this is immune, completely resistant. So the gene is having a very, very big effect on the phenotype, a major effect on the phenotype, and that's why we call it a major gene. One of the drawbacks with these major genes is that they tend to be easily overcome by rust, so notoriously non-durable. All right, these are the genes that have been used in agriculture, the resistance genes that typically, if you read, you can read about them in textbooks, they've been deployed in cultivars, and we've seen this boom and bust cycle where the pathogen has acquired virulence and the resistance gene has broken down. This is what we often say, the resistance gene is broken down. The reality is, the resistance gene doesn't break down. It doesn't change. It's the pathogen that changes. So that term resistance breakdown is really not strictly true, but it's something that farmers talk about. but the resistance of a variety has broken down. So this is a typical feature of these major genes for resistance. It's not 100%, but it's a general feature of these major genes. The minor genes tend to be adult plant resistance genes. So these are genes that are not effective in seedling growth stages, in the early growth stages. Somehow, we don't really understand why, but the genes become effective as the plant ages. All right? They tend to be minor or slow rusting, they're often called. So they have a minor effect on the phenotype. To show you what I mean by that, these would be all, this is stripe rust on wheat, by the way. So here we have our major gene down here, and this is complete susceptibility, but all of these phenotypes here we would consider to be resistant. All right, different levels of resistance, and these ones in here, more or less we would say, are being conferred by genes of minor effect, because you can see the effect of those genes on the phenotype is less. It's not having that really strong effect on the phenotype. It's a more minor effect. One of the things, and this was mentioned by Dr. Joshi the other day, they are often additive. What does that mean? Additive resistance. What it means is that you can take a gene like this. Let's just assume that there's a single gene giving this phenotype here, and a different gene that gives a phenotype like this, and put them together in one variety and end up with a phenotype like that. All right, so it's like saying 1 plus 1 equals 5. There's additivity between some of these genes. Not all of them, but some of them are definitely additive. They tend to be durable, but notice how I say tend. So they have a greater tendency for durability, but that doesn't mean that they're all durable. And we do have some cases, some examples, where some minor adult plant resistance genes have actually succumbed. They've been overcome by rust pathogens. But it's fair to say that more often than not, they tend to be durable, particularly so, more durable than the major genes. And one of the other really interesting things that we've found in the last 20 years is that some of these minor genes, these adult plant resistance genes, confer resistance to more than one pathogen. So there's this gene in wheat called LR34YR18, PM38. It's a single gene, it's been cloned, so we know it's only one gene, but it gives resistance against leaf rust, stripe rust, stem rust, powdery mildew, and one or two other diseases. I can't remember what they are. Is that bipolaris? Yeah. So this is a single gene that actually confers resistance to a whole range of pathogens. And LR34YR18 is not the only one. We know of at least two or three others in wheat that give this broad spectrum resistance. So they're really, really useful to breeders.